So in this question, the diagram below shows the value of first ionization energy for sodium and magnesium. On the diagram, add a cross to mark the approximate position of value of aluminum and then for silicon. So for aluminum, because there will be moving from group 2 to group 3, there will be a shielding effect of the orbitals, and due to the shielding effect of the orbital, the aluminum will be lower than that of magnesium. And move for silicon, again it will increase. So aluminum, it should be between sodium and magnesium, you can mark. So for aluminum, it's approximate, so you can mark here. And for silicon, it will be higher. Justify your suggested value in terms of atomic structure and electronic configuration. So how we justify this, why we mark aluminum below and silicon higher. So justification for aluminum, because for aluminum, the electron is lost from the 3p orbital. So which is having a more or greater shielding effect. Because when we write the electronic configuration for magnesium, it says 1s2, 2s2. It is 1s2, 2s2, 2p6, 3s2. But when we write for aluminum, it is 1s2, 2s2, 2p6, 3s2, 3p1. So you can see here more inner shell electrons or inner orbital electron, and this is having less inner orbital electron. So this electron will experience greater shielding effect, so it can be removed easily. So aluminum, the answer, when you write this answer, you will mention that aluminum electron lost from 3p, which has greater shielding effect, so smaller ionization compared to magnesium. And why silicon you made it at the top? Because it has more proton, so greater attraction towards the nucleus, higher ionization energy. Is this clear? The reason for why aluminum we put below than magnesium, and then silicon we put higher. So even though the aluminum is proton number increases, but the second thing is the shielding effect is higher. That shielding effect causes a decrease in value. But aluminum and silicon have the same shielding effect. Why they have the same shielding effect? Because when we write for aluminum, the configuration for aluminum and configuration for silicon, so this is 14 and this one is 13. So when we write the electronic configuration, this one is 1s2, 2s2, 2p6, 3s2, 3p1. And when we write for silicon, 1s2, 2s2, 2p6, 3s2, 3p2. So you can see same number of electron in the inner shell. So both have the same shielding effect, but because silicon having more proton than aluminum, so stronger attraction, that's why higher ionization energy. Is this clear? Which of the following graph not drawn to scale best represent the trend of melting temperature across the period? So across the period, what happened? Like you have group 1, group 2, 3, 4, then 5, 6, 7, and group 8. So for first 4 groups, the melting temperature increases and then decreases. What's the reason for that? Because these are metals, small size of positive ion, stronger attraction. That's why the melting point increase. Why group 4 is having the highest melting point? Because it will have a giant structure. Then group 5, 6, 7, and 8, they have simple molecular structure. That's why the melting point decreases. So what could be the right answer? Trend shows the trend of. What could be the right answer? Shows the change in the melting temperature across the period. So A is the correct answer. You can see increases for first 4 and then decreases. Ionization energy provide evidence for arrangement of electron in an atom. Write an equation, include a state symbol to show second ionization of magnesium. Second ionization, what does it mean? When you remove the second electron. So one electron is already removed and you're removing the second electron. So magnesium, already you remove one electron. It is in a gaseous state. You supply energy so that you remove the second electron. That's called second ionization energy. State symbols are always important when you're writing ionization. Give 2 reasons why the second ionization of magnesium is higher than the first. Like when I remove the first electron from magnesium, I need smaller amount of energy as compared to when I remove the second electron. So what is the reason for that? Why the second ionization energy is higher than that of first ionization energy? So the reason here, as we know, because electron in second ionization, we have to remove electron from the positive ion. Here, this was a neutral atom. We just supply energy, we remove. But this is a positive ion, so positive ion will attract the electron. So it will be difficult to remove the second electron. So the answer here, electron in Mg plus charge is removed from positive ion and closer to the nucleus. How closer to the nucleus? Because what happened, as electron is lost in the beginning for magnesium, there are 12 protons and they are attracting 2 electrons in the last shell. But when one of the electron is being lost, now the 12 protons are attracting 11 electrons. So each proton will experience stronger attraction. So greater attraction from the nucleus to outer. That's why it will be difficult to remove electron or the higher ionization energy, second ionization energy will be higher than that of first ionization. So it's two reasons. Number one, the first reason, electron in magnesium removed from positive ion. That's the one reason. And the second, what is the second reason? Second reason, because greater proton to electron ratio. So more attraction for each electron. Is this clear? So greater proton to electron ratio, more attraction for each electron. That's why it will be higher ionization. And the first one is electron in magnesium is removed from the positive ion, and positive ion will attract the electrons. So it will also be difficult to remove electrons. These are the two reasons why the second ionization is higher than the first. And this is for every element. Like example, if they ask instead of magnesium, if they say why the second ionization of aluminum is higher than first, or why second ionization of sodium is higher than the first. So these are the reason. In case of sodium, it will also be one reason that the shell also changes, because when we remove the electron from last shell and we want to remove the second electron, so second electron is from inner shell, so it will have a greater second ionization as compared to other elements. Is this clear, this explanation? Complete the table by suggesting a value for third ionization of magnesium. Look, when you write the electronic configuration for magnesium, as we know, if I write the electronic configuration for magnesium, it is 1s2, 2s2, 2p6, 3s2. So first two electrons are removed from s orbital. So this is from 3s, this is from 3s. This one I should remove from 2p, but all of them are removed from 2p. So means there should be a big jump here. This should be a big jump. This value should be closer to the fourth, third and fourth should be closer, but second and third should have a big gap. So what could be the suggested value? So any value is acceptable from a range from 5,000 to 9,000. Any value is acceptable. Because not an exact number they need. Like you have just suggest the values. For example, if you suggest 7,000, you suggest 8,000, all are acceptable, because this is 10,500, only 2,000 difference is there. This one, sorry, approximately 3,000 difference. So this may have 2,000 or 3,000 difference as well. But there should be a big jump from second to third ionization. So we have to write the electronic configuration for phosphorus and sulfur. So when we write phosphorus, it will be 1s2, 2s2, 2p6, 3s2, 3p, sorry, 15 we have to arrange, so 3p3 will be there. And for this one, 1s2, 2s2, 2p6, 3s2, 3p4. So when we arrange for phosphorus, electron in a box model, if I arrange, So this is electron in a box model for sulfur and phosphorus. This one is 1s, 2s, 2p, 3s, 3p. So 1s2, 2s2, 2p6, 3s2, but 3p3, so each will have single electrons. But when you write for sulfur, 1s2, 2s2, 2p6, 3s2, and 3p4. So 3p4, first there will be a single and then there will be a pair. So you can see here there's a pair of electrons are like charges, so they repel each other. So it will be easy to remove this electron out as compared to these electrons which are occupying singly. So how we will write this answer? So we will first mention that in sulfur there is a spin pair of electron. There is a spin pair electron or pairing has occurred. Shows greater repulsion between electrons, which make easy to remove electron from sulfur compared to phosphorus. Is this clear? As you writing this, you will get 2 marks. Which row in the table shows the number of proton, neutron, electron in a fluoride ion, which is -1. Fluorine is 9. Fluorine is have 9 and 19, which means it has 9 protons, 9 electrons, and 10 neutrons. But they are asking for fluoride ion. If ion is there, number of electrons should increase, so it should have 10 electron, 10 neutron, but the proton will remain 9. So D will be the right answer. The first 6 ionization energies are given for an element. In which group of a periodic table this element belongs to? So can you judge which group it belongs to using these numbers, the values? So when you check 1000, 2000, 4000, 6000, and 37,000. So there's a big jump from 4th to 5th. So if there's a big jump from 4th to 5th, it shows that it belongs to group 4. Then complete the electronic configuration for phosphorus. So 1s, then this is 2s, 2p, 3s, 3p. So 1s2, 2 first singly they will occupy, 2p6 is there, and then pairing. Then 3s2, then 3p, because we have to arrange 15, so this will be singly they occupy. This is a electron in a box model for representing the arrangement of electron in sulfur. Sorry, in phosphorus. Sulfur was the previous one, so this was phosphorus. Then the first ionization energy generally increases from left to right across the period. Explain why the first ionization of energy of sulfur is lower than of phosphorus. So we just discussed this question because in sulfur there will be a pairing of electron in the p orbital. I just wrote the answer that if this is phosphorus, but in case of sulfur, there will be a pairing of electron in sulfur, and due to this pairing of electron, more repulsion between the electrons, so it will be easy to remove electron in sulfur as compared to phosphorus. Write equation to show the third ionization of phosphorus. So we already removed one of the electron. The two electrons are already removed, and we want to remove the third electron. Whenever you write ionization energy, it is always a positive charge. So this is the equation. 1 mark is for correct state symbol and 1 mark is for the proper charges and electrons. So this is the equation for the third ionization, like removing the third electron from phosphorus. Explain why the first ionization of nitrogen is greater than phosphorus. So nitrogen, when you check nitrogen, nitrogen is 7. So nitrogen is 7 where phosphorus is 15. When you write the electronic, whenever you try to write the answer, better write the electronic configuration so that you can understand. So you can see here for nitrogen 1s2, 2s2, 2p3. For phosphorus 1s2, 2s2, 2p6, 3s2, 3p3. Now here you are removing electron from 2p, and in case of phosphorus you are removing electron from 3p. This is of 3 marks, so you should explain 3 points. When you check the first point, electron is removed from second shell, here electron removed from third shell. So that's why the first thing, why nitrogen is greater, because electrons are closer to the nucleus. That's the first point. Then the second point, you can check the shielding effect. Here inner shell having 4 electron, inner shell having 12 electron. So greater shielding effect for phosphorus, so smaller ionization energy. Is this clear, this point? So number of shells are different, fewer shells are there for nitrogen, so electrons are closer, greater attraction and shielding effect. So greater shielding effect in phosphorus, so smaller ionization. So first mark is for mentioning nitrogen has fewer electron shell. Second mark is mentioning the shielding effect, and third mark is mentioning the attraction. So electron closer to nucleus, greater shielding effect, and the third point is for mentioning greater attraction in nitrogen. Compared to phosphorus. Is this clear? So this was a discussion related to ionization and mass spectrum, and ionization mass spectrum we already discussed. We are discussing ionization energy questions. Still, there are a lot of questions you can see here. We finished some of them. So we will continue this discussion next class as well, so that you have a better understanding of this topic. Any doubt related to the class today?